is a domain and a range? Domain means that all possible x values, and a range means that all possible y values. Okay, for a straight line graph, what is a domain? What does domain means? Domain means that a straight line goes forever left and right. Okay, what does that mean? It means that all real numbers, okay, it means that all negative values and all positive values. Okay, you can also write it like this: x is an element of real numbers. Same applies as the range. Range means that a straight line goes up and down. Okay, a graph exists in all negative values and in all positive values. Okay, and what else? You can write it like this: y is an element of real numbers. Okay, let's check an example. Okay, is my pen. So let's say that the graph, sorry, my pen though. Okay, let's say that the graph is, okay, let's say it's here in the origin. For a domain of x values to the right and all positive x values to the left. These lines means that this graph is continuing. Okay, even upward, it's moving up. You can see that it's going all the way up and going all the way downwards. That's where this comes from. Okay, for a quadratic function, a domain means that where does your graph exist in x axis and where does your graph exist in y axis. Okay, so a domain in a quadratic function means that the graph continues forever left and right. It means that x is an element of real numbers. It means that all negative values and all positive values. Okay, and then what about a range? A range is slightly different because a range limits us. Okay, so for you to find a range, you first have to find a turning point. Okay, for example, y is equal to x squared minus 4x plus 3. So to find a turning point here, you use for an x value of a turning point, you use this formula: y is equal to negative b over 2a. So x is equal to negative of negative 4 over 2a, right? So x is equal to 2. And then for your y coordinate of the turning point, you substitute x in the equation. All right, substitute x in the equation. So y is equal to 2 squared minus 4 plus 3. So y is equal to negative 1. All right, so what does this mean? It means that the graph, can we draw this? If we can draw this, just wasted my paper again. If we can draw this, so x is 2 and y is -1. So they meet here. X is 2, y is -1. Okay, +2. All right, means that your graph could be like this. Okay, your graph could be like this. What does it mean? It means that a graph cannot go below -1. A graph cannot go below -1. Okay, so it means that a graph can be equal to -1 but cannot go below -1. All right, so how do you write a range in this manner? Okay, for a range you can say that y is greater than or equal to -1. What does this mean? You know that values above 1, values that are here before -1 are all great values. They are all greater than -1. So what does that mean? It means that when y is greater than 1, the graph exists when y is greater than 1. That could be your negative 0,9, negative 0,8, all the way to 0. Okay, the graph exists when y is greater than -1. Or you can say that the graph exists when y is equal to 1. This is greater than or equal to -1. Okay, so you can say that, you can also write it like this. Okay, a graph is from -1 is equal to or -1 all the way to the positive infinity, because you know when you're going up, you're going to the positive side, all the way up to the positive infinity. Okay, a domain and a range in a hyperbola. Let's say you are given y is equal to 2 over x minus 1 plus 3. Okay, x minus 1 is equal to 0. That means x is equal to 1. That means p is equal to 1. What does this mean? The graph can never touch this line. Okay, the graph can never touch this line. And what is your q? Q is equal to 3. It means that the graph can also never touch this line. If you were to draw this, q is your vertical asymptote, right? And p is your horizontal asymptote. Okay, so it will be like this. It will be like this. Graph never touches this line, a graph never touches this line. Okay, so how do you write it? You can write it like this. A domain means that this graph can exist everywhere. I mean, the graph can exist everywhere in the Cartesian plane, but not where x is equal to 1. The graph can exist everywhere, but not where x is equal to 1. And for a range, the graph exists everywhere in a Cartesian plane, but where not y is equal to 3. That's how you put it. A domain and a range in an exponential function. Let's say you are given y is equal to 2 to exponent x plus 1. Remember, a domain is where a graph exists in x-axis. So, in this instance, your domain is x is an element of real numbers. Okay? What does this mean? It means that every x value that you can put in this x here, it will give you a value which is a real number. Okay, right? It means that your graph can occur or can exist everywhere in this in x-axis. Okay, and then for your range, And then for your range, Q is equal to 1, right? Let's draw this. Let's draw this. Let's draw this. Let's say asymptote is here. That means that the graph can only exist above this line in y values. Okay, the graph can only exist above positive 1 in y values. Okay, so how do you write a domain, a range in this manner? The graph only exists on values that are above 1, 2, and infinity. Okay, 1 is not included in that in those values because 1 is an asymptote. So remember, an asymptote, a graph cannot touch an asymptote. So the graph exists on all values of y that are above 1, 2, and infinity. Okay, that's how you write it. Okay, so you can also write it as like this: y is greater than 1. What does it mean? It means that the graph exists to all values that are greater than 1 in y-axis. Okay, the graph exists in values that are greater than 1 in y-axis. That means all above here. Okay. You can use this table to remind yourself